Let us find the resultant of the following vector. Let's see, we have vector A, which is 100 meters, 30 degrees north of east. We have vector B, which is 200 meters, 50 degrees west of north. And vector C, which is 150 meters south. Using the following equation, we can compute for the resultant of our vectors. So the magnitude of the resultant is equivalent to square root of rx squared plus ry squared. To compute for our direction, we have theta is equivalent to arctan of r sub y over r sub x. To compute for the horizontal component of our resultant, we just have to get the summation of all the horizontal component of the given vector. In this case, we have r sub x is equals to a sub x plus b sub x plus c sub x. Same with the vertical component of our resultant. R sub y is equals to a sub y plus b sub y plus c sub y. Let us use this diagram to draw our given vectors. Vector A is equivalent to 100 meters, 30 degrees north of east. This is where 30 degrees north of east lies. Let us find the x and y component of our vector A. To compute for the x component, we have a sub x is equals to positive a cosine theta. So our horizontal component lies on the positive x-axis. That's why we will use a positive magnitude. Substituting our value, which is 100 cosine theta, we will get 86.6025 as our a sub x. Let us now compute for our y component. Y component lies along the positive y-axis, so we will have positive a sine theta. Again, we will use a positive component since our y component lies along positive y-axis. Substituting our given, we have 100 sine 30 degrees. Therefore, our a sub y is equivalent to 50. Okay, we can now compute for the x and y component of our vector B. Vector B is equivalent to 200 meters, 50 degrees west of north. This is where 50 degrees west of north lies. It is easier if we will get the value of our angle along the negative x-axis. So to compute for that, we just need to subtract 90 degrees to our given angle. Therefore, we have an angle of 40 degrees here. Using 40 degrees as our theta now, we can compute for the x and y component of our vector B. B sub x is equivalent to negative b cosine theta. That's because the x component of vector B lies along negative x-axis. Computing for our x component is equivalent to negative 153.2089. Next, let's get the y component of our vector B. The y component of our vector B lies along positive y-axis. Therefore, we will use b sine theta as our formula. Substituting the values, we have 200 sine 40 degrees. That's equivalent to 128.5575. Next, we have vector C, which is equivalent to 150 meters south. This is how we draw 150 meters south. We don't have an x component because our vector C lies along negative y-axis. Our y component is equivalent to negative 150. Using our formula for the magnitude and direction of the resultant, we need to get the summation of all the horizontal component and all the vertical component. Let's get the summation of all the horizontal component first. Using our computed value, we have R sub x is equivalent to negative 66.6063. Let us now compute for the summations along y-axis. Again, using our computed values, we have R sub y is equals to 28.5575. Substituting our R sub x and R sub y, we will get the magnitude of our resultant, which is 72.4703 meters. This is how we draw our x and y component along our Cartesian plane. We have a negative x component and positive x component. Therefore, our resultant lies on the second quadrant. To compute for the direction, we will use arctan of ry over rx. This is equivalent to negative 23.2073. So the angle here is equivalent to 23.2073.